With the wide variety of delivery methods available on FMS, it's easy to get confused by all the protocols and streaming methods. Let's take a moment to define some of these key terms. First, what is a delivery protocol? In this course, I refer to delivery protocols a lot. The technical definition of a protocol is a set of computer rules that provide uniform specifications so that computer hardware and operating systems can communicate. In our usage for video streaming, a delivery protocol refers to the route video data takes to get to you and the rules it needs to follow to get there. For example, HTTP dynamic streaming videos are sent over HTTP, and they must be broken into fragments before sending. Then you put them back together for playback. FMS supports RTMP, RTMFP, and standard HTTP protocols. The technical details of these protocols were discussed in depth in Chapter 2 of this course. Once a delivery protocol is established, then there are various methods of sending that video data over that connection. Let's look at two of those methods, progressive delivery and streaming. Progressive delivery, or progressive download, is the most basic form of video delivery. The file is served from a standard web server through an HTTP request, just like a normal web page or any other downloadable document. This is the method that sites like YouTube and Vimeo use for serving their videos. When the video is played using progressive delivery, the entire video file first begins to download to the viewer's hard drive, and then playback starts. The video will begin to play when enough of it has downloaded to the viewer's hard drive. This amount is referred to as a buffer. Progressive delivery, although delivered over the same protocol as HTTP streaming methods, is not as efficient. Streaming delivery consumes less bandwidth than progressive delivery because only the portion of the video that's watched is actually delivered. What is a codec? There are two other downsides to progressive download that make it less attractive than streaming. Taking raw data, it's not possible to seek the formula of the encoder that hasn't been downloaded. The data is referred to as the codec. You can see this here on Vimeo. When I click on this video and start to play it, I will click forward ahead of the buffer and try to jump to that point, and it won't let me do that. And MP3 and also Nellie Moser for audio. AAC audio does require an extra license when used for live streams, and we'll discuss that later when we set up our live video example. Now, different codecs compress the data, and video data is cached on the video file compressed using could be retrieved. Now, this is not good for copyright and sensitive content video, but the image quality might be about the same. Streaming delivery there can be other differences sometimes as well. For example, the technical definition of streaming alpha channel is for video data being transmitted in a continuous flow, but you can take advantage of hardware acceleration. There are two approaches to streaming. Not so RTMP is considered since HDS and HLS streaming open connection between the server and the client, and then data flows continuously. And AAC for audio. The bits are discarded for all of the video examples in this course. Then there's HTTP streaming, where video data is requested in small fragments from the server and then put back together into a stream by the client when it's received. And it plays like a true stream and can even support live video with a bit of a delay. One key difference is what happens to those bits. Instead of being discarded, as with RTMP streaming, they're cached on the client. So HTTP streaming isn't as secure as RTMP. And there are two formats that support HTTP streaming with Flash Media Server. HDS for playback in Flash, and HLS for playback on iOS.